Hello, welcome to this lesson. In this lesson, we're going to be conducting a hypothesis test for a population proportion using the p-value approach. First, we're going to go through the main steps that you need to take to conduct the hypothesis test. And then we have two examples where we're going to be conducting the hypothesis test. Recall that in hypothesis testing, we use statistics to make a decision about a parameter. In this case, we're going to be using the sample proportion to make a decision about the population proportion. Let's start with step one. In step one, you need to state the null hypothesis, the alternative hypothesis, and the significance level. Now, recall that the null hypothesis is a claim being made about the population proportion. The null hypothesis is always going to have an equal sign. And in this case, because we're running a hypothesis test for a proportion, we're going to always have p equal to some value. There's going to be a specific value. I'm denoting this specific value with p naught. So again, p is going to be equal to some value, the value that someone's claiming the population proportion to be equal to. Now, the alternative hypothesis can either have a less than, greater than, or not equal to sign. If the alternative hypothesis is p less than the claim value, then you're going to be running what we call a left tail test. Notice in step 4, we're going to be finding the p-value by finding the area on the left tail. If the alternative hypothesis states that p is greater than p naught, then we're conducting a right tail test. Here in step 4, when you're finding the p-value, you're going to be finding the area on the right tail. Now, if the alternative hypothesis states that p is not equal to p naught, then we're running what we call a two-tail test. In that case, you're first going to need to find the area on one of the tails, and it's going to depend on the problem. It might be the case that you are able to find the area on the left tail, or it might be the case that you're able to find the area on the right tail. We don't know. It's going to be different for every problem. You're going to find the area on one of the tails, then you're going to be multiplying it by 2, and that will give you the area on both of the tails. So it's really important for you to state the right alternative hypothesis, because that is going to guide your thinking on step 4. In step 2, we're going to assume that all the conditions are met for us to claim that the p-hat distribution follows a normal distribution with a mean equal to p naught and a standard deviation equal to the square root of p naught times q naught over n. Notice what we're doing here. Previously, I mentioned that when we carry out a hypothesis test, we assume that the null hypothesis is true. Okay? We don't have evidence to claim that it's not true. So throughout the whole test, we're assuming that p is equal to p naught. In other words, we're assuming that we have a normal distribution, which is p hat, and we're assuming that the center of this distribution is equal to p naught. So that is really important because this is going to help us work with the distribution. So the center of the distribution is going to be p naught. The standard deviation of the distribution is going to be the square root of p naught times q naught over n. Now, remind yourself that q naught is 1 minus p naught. Okay? So if we have p naught, we can find q naught. Now, next, we're going to find the sample proportion, which is p hat equal to x over n. Here, x is the number of successes, and n is the sample size. Now, next, we have step 4, which is the most challenging step of the hypothesis test, because here you need to find a probability. Okay? Now, recall that the p-value is the probability of obtaining a sample proportion as extreme or more extreme than the sample proportion you observe. So let me emphasize this part. We're assuming that the null hypothesis is true. That means that we're assuming that the center of this distribution is p naught. And we're asking ourselves, what is the probability of observing a p hat as extreme or more extreme than the p hat we found? If you're conducting a left tail test, when you find p hat in step 3, you're going to notice that your p hat is on the left-hand side of p naught. So your p hat is going to be somewhere here. In this case, you're finding the probability of a sample proportion being less than your p hat. Now, recall that this distribution is a normal distribution, so we're going to be using the normal CDF function on the calculator and the norm.dist on Google Sheets and Excel. On a calculator, you need to state your lower bound, your upper bound, the mean, and the standard deviation. The lower bound is going to be a really large negative value, and the upper bound is going to be your p-hat. Then you're going to state the mean and the standard deviation. That is going to give you the area below p-hat. If you're doing this with Google Sheets or Excel, you simply need to provide the p-hat value, the mean, and the standard deviation, because remember, this function is going to always give you the area to the left of the p-hat you enter here. Now, if we're running a right-tail test, on step 3, we're going to find a p-hat that is above the p-naught value. It's going to be here on the right side of the distribution. In this case, you're wanting to find the area above p-hat. If you're using a calculator, your lower bound is going to be p-hat. Your upper bound is going to be a really large value, which is 1E99. So again, you have your lower bound, your upper bound, and then you're going to state the mean and the standard deviation of the distribution. Now, if you're doing this with Google Sheets or Excel, you're going to use the function norm.dist. You're going to enter the p-value, the mean, and the standard deviation. Remember, this function is going to give you the area to the left of p-hat. However, you want the area to the right of p-hat. So that is why we need to take 1 minus whatever the area to the right of p-hat is. So that is going to be the function that you use if you're trying to find the probability above p-hat. If you're running a two-tail test, you're going to need to find the area of one of the tails, then you're going to multiply the area by 2. So for example, let's say that in step 3, we found a p-hat that is lower than p-naught. So a p-hat that is on this side, on the left-hand side. In that case, we're going to need to find the area below this p-hat. So we need to find the area on the left tail. Here we have functions that can help us find the area on the left tail. Once we find that area, we're simply going to multiply that by 2. Okay? Now, it could also be the case that when you find p-hat in step 3, you see that the p-hat value is above p-naught. In that case, you're going to need to find the area on the right tail. That would mean that you're using the functions that we have here in the middle for finding the area on the right tail. Once you find that area, you're going to be multiplying it by 2. So again, the most challenging part of the hypothesis test is finding the p-value. I recommend that when you're finding the p-value, you take the time to drop the p-hat distribution, center at p-naught, and you shade in the area that you're trying to find. It's also going to be very important for you to label the p-hat value, especially when you're carrying out a two-tail test. Once you have a p-value, you're ready to make a decision. If your p-value is less than alpha, then we're going to reject the null hypothesis. If the p-value is greater or equal to alpha, then we're going to reject the null hypothesis. Okay? Remember, the smaller the p-value, the less likely you are to observe the sample proportion that you saw, which is going to make us think that we should reject the null hypothesis. Now here, we're saying that the p-value has to be smaller than alpha. Once you make a decision, you need to write a conclusion, and you need to use the context of the situation. If we reject the null hypothesis, then we're going to write the following. There is sufficient evidence to conclude the alternative hypothesis. Here, you're going to need to describe what the alternative hypothesis represents in the context of the situation. But the idea here is that if we're rejecting the null hypothesis, then we did find sufficient evidence to go with the alternative hypothesis. Now, if you fail to reject the null hypothesis, then we're going to write the following. There's no sufficient evidence. We didn't find sufficient evidence to go with the alternative hypothesis. Okay? And again, you're going to describe what the alternative hypothesis is. Now, let me make this big remark. When we fail to reject the null hypothesis, we are not going to say that we accept the null hypothesis. We're simply saying there's no sufficient evidence. We didn't find enough evidence to go with the alternative hypothesis. My apologies if I sounded like a textbook in this first page, okay? But it's really important for us to talk about these steps. Okay? Perhaps this is going to make more sense once we start looking at some examples.